Welcome to BrainFeed, your gateway to limitless learning. The Northern Lights, also known as Aurora Borealis, have been mesmerizing humans for centuries. These otherworldly lights are a natural wonder that can only be seen in the polar regions of the Earth. They are a result of complex intergalactic reactions that take place in our planet's magnetic field. Seeing the Northern Lights dance across the night sky is an awe-inspiring experience that has left scientists and common observers in wonder and amazement for generations. The scientific explanation behind the Northern Lights is quite complex, but it's fascinating how nature can create such an extraordinary spectacle. To understand what causes Aurora Borealis, it's important to take a closer look at the science behind it. What are the Northern Lights? The Northern Lights are a natural light display that occurs in the Earth's polar regions. These light displays happen when electrically charged particles from the Sun enter the Earth's atmosphere and collide with gas particles. The result of these collisions creates a stunning array of light that usually appears as a green, sometimes with a shade of pink or blue, and red band of light in the night sky. What causes the Northern Lights? The Northern Lights are caused by the interaction between the Earth's magnetic field and charged particles that are released by the Sun. When there is an outburst of energy from the Sun, the magnetic field around the Earth's poles is affected. It causes the magnetosphere to compress on one side and stretch on the other, which results in high-energy electrons being flung into the Earth's atmosphere. These high-energy particles then collide with the oxygen and nitrogen particles in our atmosphere, emitting a spectrum of colors of light. The colors depend on the type of gas that is present in the atmosphere and the altitude of the collision. The Northern Lights are visible in the polar regions because the Earth's magnetic field is weaker at the poles. This weaker magnetic field means that the charged particles can enter the atmosphere more easily, resulting in a more intense light display. How are the different colors formed? As we mentioned before, the color of the Northern Lights depends on the type of gas particles in our atmosphere. The most common color is green, which is caused by the collisions of charged oxygen atoms at an altitude of approximately 100,300 kilometers. When the oxygen atoms collide, they release photons of green light. In addition to green, the Northern Lights can also emit other colors such as red, blue, and even violet. These colors occur when charged particles collide with atmospheric gases at different altitudes. For instance, a red hue appears when charged particles collide with oxygen molecules at an altitude of about 200 kilometers. Blue and violet lights occur when charged particles collide with nitrogen molecules. The intensity of the light display can vary depending on the strength of the solar storm and the amount of energy that is released. In some cases, the Northern Lights can be bright enough to cast a shadow on the ground. When is the best time to see the Northern Lights? The best time to see the Northern Lights is during the winter months, September to March, when the nights are longer in the polar regions. However, you also need clear skies to see the Northern Lights as clouds can block the view. The Northern Lights can be seen from many areas in the Arctic regions, including Norway, Canada, Alaska, Sweden, and Finland. It's worth noting that the strength and frequency of the Northern Lights can vary depending on the solar cycle. The solar cycle is a period of approximately 11 years when the Sun's activity, including the release of charged particles, fluctuates. During periods of high solar activity, the Northern Lights are visible more frequently and appear brighter. The scientific significance of the Northern Lights. The Northern Lights are not just a beautiful natural phenomenon but also have scientific significance. Scientists have been studying the Northern Lights for many years and continue to do so to learn more about our planet's environment. Some of the scientific discoveries made through Northern Lights research include: 1. Understanding magnetism. The Northern Lights provide important information on our planet's magnetic field and how it works. By studying the Aurora Borealis, scientists have been able to learn more about how the magnetosphere interacts with charged particles from the Sun. This has helped us learn more about the Earth's magnetic field and its importance in protecting our planet from harmful radiation. 2. Learning about climate change. The Northern Lights can also provide valuable information about climate change. By analyzing the composition of the layers of the atmosphere that collide with the charged particles, scientists can learn more about changes in the atmosphere over time. 3. Advancing space exploration. Finally, the study of northern lights can help us advance our knowledge of space exploration. Many of the same processes that occur in the northern lights can be found on other planets and even in other stars. By studying the Aurora Borealis, we can gain a better understanding of how these processes work and how to explore space safely. In conclusion, the northern lights are a beautiful natural wonder that has been captivating humans for centuries. While they are a stunning sight to witness, they are also an important scientific phenomenon that provides valuable information on our planet's environment. The study of Aurora Borealis has led to significant discoveries in magnetism, climate change, and space exploration. As we continue to learn more about the fascinating science behind the northern lights, we can gain a better appreciation for the natural wonders of our planet and the universe beyond. Thanks for watching BrainFeed. Consider liking the video and subscribe to our channel for daily educational content.